Hello, this is Math 2231 coming to you from the College of DuPage during the summer of 2020. And this is the conclusion of our lecture, Extreme Value Theorem and such. Last time I closed the segment asking you to work on this problem. I hope you solved this, but if not, you could have another chance here. You know what to do. Let's see how you did. Well, we have to evaluate the endpoints, but also see if there is a critical point in between, or maybe multiple critical points in between. So we're going to take the derivative. So g prime is going to be equal to this. You should check these calculations. And we're going to be setting this equal to 0, so we will factor it, and we'll get minus 2 and 1 as the values, and both of those are inside this interval. So that means we have to evaluate both of these in addition to the endpoints. So we do that, and we'll see what is the biggest n, what is the smallest. So you see, what we see is the absolute maximum of g of t is 24, and that happens at t equal minus 2. And the absolute minimum of g of t is negative 28, which occurs at t equal minus 4, and end point. Here's another problem for you to do. You know what to do. Let's see how you did. Now, you might have thought I gave you exactly the same problem, but I didn't, because I changed the interval. So you see that changes what we have. 1 is the only one of those critical numbers that falls inside that interval, so that's the only one that we evaluate in addition to the endpoints of this new interval. So we plug those into g, do the calculations, and we see that the absolute maximum is 8, and this will occur when t is 2, and the absolute minimum is minus 3, which occurs when t is equal to 1. Let's do another problem. Now this is a word problem and really speaks to the kind of applications you could run into. Suppose that the population in thousands of a certain kind of insect after t months is given by this formula, and you see this could shift seasonally with respect to the months as you know, it's colder and warmer and so on and so forth. So this is the equation for p of t, the population in thousands, and we want to determine the minimum and maximum population in the first 4 months. So we're going from 0 to 4 is what t is going to go. You know what to do and when to do it, and you will need a calculator on this one. Let's see how you did. Okay, so we're trying to find the absolute extrema, minimum and max, of p of t on the interval 0 to 4. And the function is continuous everywhere, and so we know by the extreme value theorem that this exists. So we take the derivative. So the derivative of 3t with respect to t is 3. The derivative of the sine of 4t is going to be 4 cosine 4t because of the chain rule, and the derivative of the 100 is 0. So we're going to set this equal to 0, and we're going to solve. We subtract the 3 and divide by 4. So the cosine of 4t is minus 3 over 4. Now this is not a special triangle that you know of, and so we're going to resort to our calculator, and we're going to find the inverse cosine is this, and that's in the second quadrant. And the cosine is also going to be negative in the third quadrant. And so I say 2 pi minus the answer from this one, and I get the numbers that you see here for 4t. Now, these can be plus 2 pi n, where n is any of these integers, and I can divide by 4, and I divide 4 here, and I divide by 4 here, and so I get these expressions for t. But not all of those are going to be in the interval from 0 to 4, which is what we're interested in. So we have to check which ones fall in. So we're going to be doing a bunch of substitution here, as we did in the other problem that we did as an example. And we'll find that there are 5 critical points that are in that interval from 0 to 4. This is what they are as decimal approximations. And so now we want to determine the endpoints 0 and 4, and also these 5 values, and we see which are the biggest. So from these evaluations, the minimum is 100,000, and it occurs when t is equal to 0, and the maximum is this number when t is 3.7 and change. Here's another problem, word problem, dealing with, suppose the amount of money in an account is given after t years by this. And again, there can be fluctuations that happen in money markets. And you see you have a factor of t times this. So we're going to be taking a product rule when we take a derivative of this. We want to determine the minimum and maximum amount of money in the account during the first 10 years. So we're going from 0 to 10. You know what to do. Let's see how you did. So we are going to take the derivative of a of t. The derivative of 2,000 is 0. And this is the product rule. So we're going to have minus 10 times 1, that's the derivative of t with respect to t, times a second. And that's going to be minus 10t times the derivative of e to the u with respect to t. So it's going to be e to the u times du dt by the chain rule. And now I have a common factor of 10 and e to the 5 minus t squared over 8. So I can factor that out, and this is never going to be equal to 0. So if I set this derivative equal to 0, it's the same thing as saying that this factor is equal to 0, and that tells me that t is plus or minus 2. But only one of those critical values is in the interval from 0 to 10, and that's t equal 2. So I look at the endpoints 0 and 10, and then I substitute 2, which is this one, in, and I see that the maximum happens at 2,000, which is at t equals 0, and the minimum will be this at the 2-year mark. Here's another problem for you to attempt. So find the absolute extrema for the following function on this closed interval. You know what to do? Let's see how you did. Now, this is the function, and when you take the derivative, we're using the product rule. So it's the derivative of the first times the second plus the first times the derivative of the second. This is 2/3 y plus 4 to the minus 1/3. Now, that means we have this plus this after we simplify. We're going to get a common denominator, but notice we do have a denominator, so we have to be careful about that. So we're going to multiply top and bottom over here by the quantity y plus 4 to the 1/3, and that will give me 3 times y plus 4 plus 2y all over this. And when we simplify the numerator, we get this. But now we have two possibilities. We have a critical point where the denominator is equal to 0, that is at minus 4. And when the top is equal to 0, that is at 12 over 5. So we've got two critical points. And both of these critical points are in the interval. So we have to evaluate the endpoints of the interval as well as these critical values. And the function then has an absolute maximum at 0, a maximum of 0 at y equal minus 4, and the function will have an absolute minimum of minus 15 at y equal minus 5. In closing, now more than ever, time is precious. Each day must count. Do the math, it will make you strong. And now, more than ever, take care of yourself and of each other. God bless.